So many people ask, what is microgravity? Why do you float on board the International Space Station? Gravity acts upon all objects. We're never truly in zero gravity on board the space station. But because the space station is traveling so fast around the surface of the Earth, we're actually in a constant free fall. And that's why everything and everybody appears to float on board the space station.
We are experiencing the Earth's gravity. In fact, we're actually experiencing about 90% of what you all experience on the surface of the Earth. The difference is we're just moving so fast that as we fall, we actually fall around the Earth, and that defines orbit. So microgravity means we're not, it's not the absence of mass, which of course creates gravity, but all the objects together are in the same gravitational field and all falling together. So yes, it is a lot of fun. Floating around, of course, is one of the exciting parts of being up here on board and being an astronaut, but even more importantly, it lends itself to all the amazing experiments that we can do on board that take advantage of that microgravity environment to do things that we can't do on Earth, but that can benefit life back on Earth.
Microgravity has a lot to teach us. Take these containers. The green liquid inside is showing us how fuel swirls around in a tank while it moves through space. What we learn could help us design safer, more efficient spacecraft. At any given time, we are conducting close to 300 different experiments aboard the International Space Station. Research like this is preparing us for the future of space exploration.
That's cool.
Development or technical processes like combustion or fluid flow. And it helps you understand things that you may not have fully understood on Earth, where you see something.
got you covered. Think of hydrogels like a scoop of gelatin. Not quite a liquid, not quite a solid, definitely made up of mostly water. We can use hydrogels to cover wounds and even deliver antibiotics to promote healing. For that reason, hydrogels are being studied for use for things like wound care for soldiers on battlefields.
If you are far away from a hospital or a clinic and you can't get good medical care right away, and that soldier has a wound, could you apply that hydrogel directly to the wound site and begin to treat any infection that might be coming on? What about in space though? What if we are far away from Earth's surface on our way towards Mars, and we also have another wound on an arm or a leg, and we need a better way to treat that wound and make sure it doesn't become infected? So Tympanogen, the hydrogel itself, is a great example of a dual-purpose technology. It's something we can use not only on the Earth, but up in space.
This research could provide previously unknown foundations for future hydrogel studies. It's a great example of how microgravity can offer new insights into systems we've already explored on Earth.
The data that we're collecting is so basic science that it's hard to find those sorts of projects at this stage. As a researcher, that's really exciting for us as well. And it's in space.
And when it gets to space, it goes into the hands of astronauts who will run the experiment in orbit. Just like training for launch, landing, and spacewalks, crew members participate in hours of scientific training to prepare them for running many of the hundreds of experiments that are ongoing aboard the space station. Ready to go to class with an astronaut? We'll take you along.
Well, a lot had changed in 11 years since he was up there. There was a new experiment, so he hadn't seen that either. They tell us, you know, hey, this is a lot easier if you just go upside down. You know, you're going to be in microgravity and this will work differently.